U-Sub. Because U-Sub is the best. I like it.
Isn't there only like 4 weeks till the AFC exam not happening for break?
Yeah.
That feels about right. Well, no, because we have like 3 weeks when we get that. Because ours is
Oh, yeah. I'm thinking for gum.
I know. Spring break being so late this year is a little.
No, gum sticks because the U.S. and Canada were like 2 days apart.
Yeah.
Hi, Herbie.
Yeah, we still have 3 countries left to do in comparatives. I don't know how we're gonna.
I say, at least, I promise I will teach you everything.
We just started Iran, so.
Just started
Well, we're doing our Iran test.
Hello.
We got China, Nigeria, and Mexico.
Oh, we haven't covered Mexico, China, Iran, and
Nigeria.
Nigeria.
No, I literally just said that. See the original.
No, I just. I don't know if I hit my head, but it hurt.
You got a big bunch ahead of you?
Yeah.
What time does it win? Yeah, first time. Yes,
one day.
You weren't there.
I was.
You were a manager, right? Yeah.
I did
It was good, and we won, so it was an undefeated season. And then I stopped playing. Coming from a game where we win the game like Although I gotta say the quarters we got tough with like the
Is anyone seen Substitution?
I just texted her. I don't know where she is.
I feel like she comes when she wants.
Starbucks.
That's all right. At least she shows up.
I don't know. Last time I know, she was like, I think
All right, y'all. Welcome to class. We are going to review a little bit for round 2. So when I highlighted these actually just last block. Most of the calculator questions were the ones that were a little bit messier. Some of y'all were a little silly. It's an integrals test, and you didn't do an integral on a question. So recommendation: when you're doing these, do an integral. So these are some of the calculator questions. There is one where you're not going to do an integral. I will say that. Pay attention to things that are bolded, especially this middle question. Almost everyone did the, trapezoidal, right? But then the part that was bolded, you were just like, I don't need that information. So contemplate how to use that. I have 8 questions on here. We'll go through them relatively quickly, and then we will continue on our U-Sub journey. If you've been peeking at my desk, yes, that colored piece of paper is your second to last problem set ever in this class. Wow. What a day.
So what are we gonna do after we finish all the
Review for the AP test. Seniors will probably be gone. So the AP test? May 16th is the start of outreach.
So do we just hang out?
No. I gotta contemplate. Gotta see how much time you have. In the past, I've done like a really easy intro to BC, like super easy. Yeah. Do a couple of integration techniques. Review some U-Sub because U-Sub's really important. All right, let me put a timer up. I'm gonna do time and a half on the question. So let's try 12 minutes. A lot of you are going to grab a calculator. That's a good idea. A lot of these are the calculator questions. Take about 12. I can walk around and hopefully check stuff. I haven't made names with you. Did he specifically come over and take your calculator?
He walked past the calculator. Why did you grab one?
pretend that's not very expensive.
Switch up that ad.
Y'all, I hate to like words. You guys doing any questions live?
But in the bathroom or outside the bathroom?
Yeah, that was a stairwell.
That's really
Yeah.
It sounded like the bathroom.
Oh, I missed the party.
Where's the semicircle?
Sorry, I copied and pasted the directions. There's not a semicircle.
Oh, you must be a semicircle.
If anything just doesn't make sense, just pretend it's a typo.
What is?
Then when you ask me, I'll be like, oh,
Yeah, when you like the intro to BC stuff, is that gonna be for
yes, but usually I make it like super duper nice. So in the past I've done like only mastery quizzes, so it's a huge to make it right. And we'll spend most of our time, since it's not like anything done,
Drink for water, what?
it's not really done. It should be really, really
Why not just have one thing?
And since there won't be that many of you, I know one year we got up and we were like just doing problems on the whiteboard, like not just sitting and taking notes the whole time. So it should be fun. But it's kind of boring to just get projects at the end of the year.
we should watch a movie? How do you even do a project from that?
So I've had some before. My end of year BC project is usually just take something that is in any way related to math and teach me about it for 5 minutes. So I get a couple of days.
Oh, got me surprised to die, like a short video.
Yeah. So that I did with my math classes.
I think I got the.
So it could just be like a 2-minute video on how to like.
It was like a 5-minute class presentation, and it had to be something that like I didn't know about. So a lot of people choose like science topics, black holes, existence of those certain formulas for that, certain gears. I wish I had a video presentation, because I don't remember the details, but colored. Zero. Is anyone doing these problems?
I don't know how to do a problem.
Cool, cool, cool. I just want to make sure I was
What?
Not like.
So we're just on the.
Yeah.
How do we know which one you're fine?
So you're gonna want to set up something that looks like the fundamental theorem of calculus, between the bound you know and the bound. And then a function. Yeah, so what I set up first was my integral and my f prime, which is the graph that I have, is out of the top down minus up to down. And the thing you have to do is get you back, which is the point I've told you about. And this part, this is just like the statement. Yeah, this will be your graph and one of these.
But it's 7 feet per second, not 7 feet. What do you add 7 feet per second?
Considering how it should be at times 6.
Yep.
Oh, okay, but I said.
Okay, exactly.
And then.
So I like adding the 8 onto it, that's where you start.
And you go forward, but no.
I don't like where you're ending.
So that top down should be the time.
I do too. None of the stats.
No, I like the 0 on the bottom, so you're starting at time 0 to time 8. This is like your initial position. So this is like, where did you start, and then how far did you go? And then that's just like your music for the end.
Like, what second we do it?
Oh,
Of course I do.
While we're sitting here, if you borrow my calculator, make sure you put it in reading.
You're the outreach. And, that's,
You need to force
yeah, and I'm not sure about my community sponsors.
I would keep that until you have the signatures, and if you can't get it today, I would start by doing it anyway.
I talked to,
that out too.
and she said he's
Working on that right now.
today,
Okay.
2 seconds left. Yeah.
that,
Am I your community?
We're gonna go.
yeah.
Perfect, you're fine. Perfect. All right, so if you talked to her already, then I would just make sure that everything is good to go on.
My secret advice.
Hold up, you want to hang out your mind? Cosine, zero is in your head. I think these might all be nice.
Whatever you want.
I'll email
Yeah, I'm
you
gonna say
when I
all
find
the
out.
approvals are with, your, like, with the outreach team. I really don't have anything to do with it. So you can
I understand kind of like what you're saying, but I don't understand like how you're saying it. Like I have to do it, it's not like why.
Right, so if we have to grab that, so being asked about that, the only way I can get information from that side staff as normally, kind of when we first started doing
I
this.
was no, so I was thinking around like, oh,
Like,
it'd be funny if I
equal
wrote
to, like,
this.
intervals, we still have to top down. Here we don't have that like feedback. So to relate this back, it's kind of like other integrating and plugging in our balance, you know, the anti-derivative of F times is F. And then you can plug in our top down.
25 meters, huge, right?
Right, we're choosing these bounds in our question because we want to know about F or, and the only other.
I can too, like, I know what to
The
do.
only way I know how to do F
I know
times
how to
is
do
F
F
is by integrating.
So now am I finding like 0 and 4?
Yes, that's gonna be what we plug in on this side, so an integral still means area with our graph, so I'm gonna use these 2 triangles. And then usually on this side, you're gonna have that one point that you use for.
Yes, the first one.
For F.
So I'm gonna have F of 4 minus 4
It's
with
the
the
area.
area.
Okay.
Just like look at this point, like, isn't Apple Core just like so long?
No, that's.
I know that's not actually.
So that's F prime of 4, because that's a graph, yeah.
Oh, it's just a graph.
No, I guess.
It's just painful. So, I think I did that one. I hope I did.
No.
Oh, we still have full class, don't we?
Oh, no, you're on the 3 for that.
After this, we're gonna
I know, I only have 3 problems to do today, and these 2 are gonna take too long.
Take it back right now.
Once it's full.
I can really
Well, at least right now that we pulled out.
Okay, is this like our 3rd one? I feel like we don't
We've had like any.
Yeah. Did anyone sign into a virtual book school?
I did,
You did?
yeah,
Was it really?
no. But I was the club president, so I kind of
Kind
hated
of had to.
Oh, so 1.85.
How's everyone doing?
And I have some shit.
Yes. Would love that. Just sitting up here doing something.
I don't know if it starts for the velocity.
Okay, so let's see how this works. As you trapezoidal roll with 3 equal sub-intervals, can you do that with a frequency? So think of trapezoidal rule is kind of like approximately, well, not kind of like, it is approximating the integral. So that's gonna take you from acceleration back up 1 step to velocity. So think of accelerations like velocity prime, so doing that trapezoidal rule kind of integration.
It's like 1/2.
I got you.
I know the bottom ones are like the bad end, but what about the top ones, like
No.
No, your answer, I remember highlighting yours. Your answer was really big and I was like, whoa.
Yeah, I was like, you're getting big numbers, I just think over here, I was like, okay.
All right, would we appreciate some more time? All right, how much more time do you think? 10. Let's go 8, so 20 overall. Deal? I need to take a 10.
I think I have the right.
Why are you doing this and not my review?
Well, because one of
Oh,
the
it is.
first
Yeah, that's
questions,
fair.
the first question was like pretty much like this, and
Mhm.
I thought I didn't really know. I don't know. I'm kind of stuck on it.
So if you're finding G prime, what do you think a derivative of an antiderivative should give you?
Just the that would cancel out.
Mm-hmm. So what we did was we plugged in this top function where t was.
Oh wait, so would it be 2x times 2?
So you think of like f of 2x and then times 2 for chain rule, yes.
Oh,
And
I
then
did
you'll
do
plug
that,
in
and
the
then I
one.
just erased it.
Yeah, you
Oh,
silly goose.
oops.
Derek. Probably. Oh, yes.
Okay, that makes sense.
I think yours looks really Oh, cute. Oh, it actually doesn't matter.
It doesn't.
No. Yeah, I just told Wayne how to do that, so he might be able to help you.
Oh, I didn't realize. I think I did
So
that right.
what you just found represents the concentration or the change in velocity between t equals 1 and t equals 7. Oh, I should have not changed these letters.
Why we got it wrong.
No, excuse me, my numbers.
Pretend.
It's like a good.
If the velocity
nice
is
number.
7 seconds at t equals 1, what's the velocity at the end of that 30 degrees representing your change in velocity?
The total amount?
It's supposed to be
So
negative.
like, is it each? So is this the change from 1 to 7,
Yeah.
or from change from 1 to 3, and then also change from 3 to 5?
So that's the total change from 1 to 7.
So it'd be 30,
So what could you do with that 7? I don't like to multiply. I made all the typos.
Why would you subtract it? If you divide it?
No. Let's pretend that we're positioned instead. So you're trapezoidal. Let's pretend we have velocity and we want it in position. I think it's easier to think about that way. So your integral represents like your change in position between t equals 1 and t equals 7. There you go. So essentially that 7 there is like where you started. So if I start at 7 feet per second and then I change a total of 33 feet per second,
Oh, no.
find the end, I should know that.
I don't do the absolute value, right? I
Correct.
know it wouldn't matter.
It wouldn't matter in this case, and usually we don't have like a distinction between the same way we do with like distance and displacement. We don't have that kind of distinction when we're talking about velocity problems. You might if you were asked about speed.
No, hang on.
Speed is magnitude, but hello. Did I say this? I'm not sure. Well, because I don't know how to type it. Okay, I don't understand the rate. So for rate out, what number should I use? So my bounds that are wrong? No, it's your function here. So if you're talking about how the rainwater flowing out of the drain pipe, I don't want to use the function that's modeling how much is going into the drain pipe.
Okay, and that makes sense.
Perhaps it depends.
Because I did start with change, and I added the 10 to finish.
Yeah, that's right. You just want to make sure you're adding and subtracting the right ones. You should be, I would just make sure one of those functions should be D and T. And just
And then here, what? How do I find G prime?
You gotta take a derivative of this guy. And what happens if I take a derivative of an integral? Or a derivative of an antiderivative? Just throw it out my favorite.
Yeah.
Okay.
The total growth.
Okay, and how do I find my bounds? My bounds.
You should know it bounds.
And then 30.
Well, I have no idea how you got those numbers. So on the test, I'd be able to
I mean,
exactly
yeah.
0 points.
Yeah, no, but I think Reddy is like this.
I haven't done it.
I'm just doing it this way.
Okay. I actually don't know because I didn't make an answer for you. Hello. No, it doesn't matter actually. Because of the G prime.
The average temperature, I guess at the.
Hello. Yeah.
For this one, are you setting the goal here for the total distance for the first 3 minutes of movement? So are we setting up that at 0?
I guess the average temperature.
So then am I just putting like 0? 0 to 3.
LT is your function, but what's going to be true since I said total distance and not displacement? Yes, I am.
So my absolute, am I putting the cosine of t?
This one you have to read.
So do I still take, that one's antiderivative?
Ooh, okay. So you either want to write one of two things. If you're going to plug in your cosine of t for LT, you don't need this guy. Because that is your LT. Okay. Notationally, you want to have a dt right here to close out your integral, and then I would just shove this guy in there. Yeah, should be like.
I'm pretty sure I got this one.
Make sure you keep your absolute value bars. Exactly. I could also ask that as like, how far did I travel, but or like, how far am I from the starting point at the end? That's the same thing as
I have no idea. Wait, I know.
all right. Several typos.
Is there one on like
Is there a typo on the third and the fourth question?
Yeah.
I don't think so.
Okay, so how do I start that one? There's like nothing. Take a. I have 0.
What? That's a perfectly good function.
No, but I don't think it did.
Why don't you like cosine? You gotta read. If you ever think you need more information, it is almost certainly in that top paragraph. Because on the AP test, they're like, I know you're not gonna read that.
The position of the
Where am I supposed to be at 1.5? It says it's 0 with an 8. So can I just,
So think of an integral is going to tell you how far you went.
okay.
So if I do an integral from 0 to 1.5, it's going to tell me how far the snail went from t equals 0 to t equals 1.5. What could I do with the 8 to figure out where the snail is? So
Adding the 8 to 1.5, or do I actually combine them?
you're adding the 8 to the integral that you're doing. All right, let's go ahead and talk these through. I know this is a lot of questions, and I know there were some typos. I apologize. I was a little tired as I was making this morning. So we'll go through these. If you have questions as we go, I'm going to make some comments about some things that I saw as I was highlighting. So for this first one, this one was a little bit different than some of the accumulation things we've been doing because I didn't get a function that was defined as an integral, but I was given a derivative in a graph and then asked about the original function. The only way I really know how to get from a derivative back to an original function is to integrate it. So that's going to give me some version of f of x with some bounds on it. Anyone have some thoughts on the bounds for this question? 0 and 4. Those are the only two things that I know or care about on f of x. I can't pull things off this graph because even though the prime didn't make it there, this is a graph of f prime. That means that I'm going to end up plugging in my bounds here to get f of 4 minus f of 0. It should be the graph of f prime. It said that in the question. I know. Herbie, you okay back there? Okay. We're shifting wildly. All right. How am I going to evaluate this integral here? What should an integral make me think of if I have a graph? Area, right? Looking at this, I'm going from 0 over to 4. So there's two triangles here. They are the same. Why would that matter? How do they cancel out? They're two triangles. Which one's negative? All right. So this guy counts as negative area because he is below the x-axis. That might be helpful for, say, like a multiple choice question that asks you about area and things above and below the x-axis. Most of you figured that out. So I could set these up as 1/2 base times height, but since they're the same and they cancel, that's fine. F of 4. Am I going to plug in anything for f of 4? No. That's what I want to find, so it should stay in my thing. My equation. What should I plug in for f of 0? 4. That's this point right here. You should be able to plug in that point because you should have used that x value as your bound. So I am getting f of 4 equals 4. And I know this one was kind of easy to solve. You don't necessarily have to kind of simplify your answer. I know this one was kind of already simplified, but I could leave it unsimplified if I wanted to. All right, I apologize. There was a typo because I changed it from here. This should be t equals 1. You guys did a great job at setting up this trapezoidal. Our delta x's, or I guess delta t's in this case, all of them were 2. I like using the average version of this guy. So my 1/2s are going to be all on the bottom here as 2's. And then I am adding together my a of t values. So I'm doing 8 plus 7, 7 plus 3, and 3 plus 5. Honestly, the vast majority of people set this up correctly. This should give me 33, I believe. And that would be velocity, so like feet per second. The reason it's velocity, these values on top are a of t values, so feet per second squared. This guy is seconds. You can also think of trapezoidal rule as kind of approximating an integral. So it would remove that idea of 1 prime or 1 rate of change to get back to velocity. Now, this represents a change in velocity between t equals 1 and t equals 7. So how can I get the velocity at t equals 7? Yeah, I just need to add 7. And I'll get 40 feet per second. So I know I bolded that on the test, so please use the bolded information. All right, here's where we started just plugging in the functions. All right, total distance. Tell me about it. Yeah. Yeah. Oh, no. So absolute value. Do I need to integrate this? Yeah, some of you guys just started plugging into the function. I was like, don't do that. Integrate something. What should my bounds be? 0 to 3. Evan, now do you want to tell me the answer? Would it be wrong if you didn't do the absolute value? Yes, it will be different. Hold on. Way more people than I thought. Yeah, let's talk about how to get the absolute value. So I'm going to go to math. Number 9. Let's see if Evan's right. Evan, what did you get? 1.858. Anyone else get that? All right. So I'm going to go over to num to get my absolute value. What was it? Just cosine into t? Not for this one. This one just said for the first 3 minutes. So 1.858 or 1.859, both acceptable. You can truncate or round, but I like 3 decimal places. Some of you I had to highlight for 3 decimal places, and that made me mad. 858. All right.
Can you go back?
I can.
So instead of writing the integrals like you did, I wrote mine like how it's written there. I had like the 0 that we did the cosine x dx, and then I had equals 1.8. Can I do it like that?
Without the absolute value bars?
What?
Without the absolute value bars?
No.
Or wait, what are you? Then what's different?
It's all good.
I wanted to know. I just didn't understand.
I was just trying to. I wrote it like that.
Yeah.
Instead of how you wrote it.
Oh, on your paper?
Yeah.
Oh, yeah, that's totally fine. Sorry. No, I just didn't give me a chance to understand the question. Yeah, so in this question, there aren't any units real. Oh, there are units. Did I ask for them? I did. It's bolded. All right. So here, feet. Good. So I integrate, I get feet. Yep. See, even I can miss the bolded direction sometimes. All right. The position of the snail at t equals 1.5. Thoughts on this? We should probably do an integral. Why? That's fair. We could look at it. All right. So I like the bounds of 0 to 1.5. That's going to be helpful. The reason I want to integrate is we're going from a rate of change, so essentially a velocity function, back to a position function. Should I need absolute value bars on this one? No. We're looking for displacement here. Kind of, though. We're missing something here. This represents the change in position of the snail between 0 and 2.5, or 1.5. So I want to add 8. So if you think of like, if you're running on the W90 trail, this is your mile marker where you start, and then this is how far you kind of went from that starting point. So to find your position, you need to add those both together. Did anyone do that and get a number? I'm just feeling, what? 8.997. Cool. Also feet. All right. When in doubt on this test, integrate it out, ma'am.
What did you like do for the LFT is like cosine.
Mhm.
So did you do like cosine 0? Cosine?
So here, I'm just going to let the calculator do it itself. So
Okay,
here again, yeah. So I do want to show the setup. So I want to show this, but as soon as I'm done with that, if it's the calculator section, I'm going to let the calculator do the work. As a note, you do need to show the setup though. If you just gave me this oops, that's not me circling. If I just get this number as my answer, I can give you exactly 0 points. So, all right, this guy, a bunch of people did this right. It was, I believe, like a Riemann sum. A lot of people did it right and then didn't tell me what the meaning of it was. Does anyone remember the 3 things we need when we write down the meaning? A number, units, and time with units. That's a good question. So does anyone know what this formula gives us as far as like things? A couple people got it. Yeah, it's the average value of whatever we were given. So let's talk about, this is now average temperature of water. So I could say water was on average, well, what number did I put? 82.3. So that's my number. What are the units on that number? Degrees Celsius. That's my units. And then my time with units. That would be probably using those bounds there. So I saw a couple really good examples on the, oh, I just like weirded this up. Forget this. So I would say from t equals 0 to t equals 60, using whatever units are on that t equals 0 and t equals 60. So look, yeah, so minutes here or hours, whatever you put in there. So most people got, if you did a good job at the explanation, most people got that part. You do want to make sure your time has units. You could also say over the 60-minute interval, if that's more comfortable there. You could do anything that kind of gives units to that time interval. All right, the last couple of questions. Here, I know the bottom bound wasn't on this graph. It actually doesn't matter because if I take a derivative of an antiderivative, what should happen? Effectively cancels out. We're going to take this x and plug it in. So g prime of x is equal to f of x. If that top bound had been like 2x, would I have had to do anything different? Yeah, I would have had a 2 here and a times 2 at the end, but it doesn't have a 2, so let's just keep going. All right, so if I plug in g prime of 0, that's f of 0. What is that on the graph? 4. Easy, simple, straightforward. Have to remember, though, that a derivative of an antiderivative is just the function inside. We're going to plug in that top bound. All right, I'm going to steal some answers here. So we got rate in, rate out. We have R of t, that is our rate in. Yes. This guy, our rate out. Oh, no more dust for us. All right. We want to know how many cubic feet of rainwater flow out of the pipe during the 8-hour time interval. If I have a rate and I want to go back to an amount of rainwater, what am I going to do? What calculus thing? What an great idea. All right. Which function? It's a classic. All right. What function should we integrate? D of t in this case, because we're looking for the amount that went out. What should my bounds be? 0 and 8. All right. Did anyone get a number? 413 feet cubed.
So is it okay if, because on the calculator I have reads going on, I put a second read with a line over?
Yeah.
That be okay?
Yes. So you just need to be accurate to the 3rd decimal place. So after this one, if you have any more decimal places, it actually doesn't matter if they're right, wrong, missing. As long as you are good up to here, it doesn't matter. So if you want to be like extra super careful and write 5 decimal places just to make sure you don't act, a lot of people accidentally do 2. So yeah. All right, let's talk about this last one. How many cubic feet of rainwater are in the pipe at t equals 5? Now, I had a typo on the test, so I read with you if you kind of goofed it up a little bit from not reading my mind. I accidentally had a 3 there. So if you worked with a 3, I worked with your answer. I changed them on there, though. I think you two did it right with the 3 in there. So I read with you. You're fine. So here, I want to start with 3 different things. How much rainwater was originally in the pipe? 10. I want to add on how much went in there, which should be me integrating from 0 to 5 of the rate in, R of t. Thank you. And then subtracting how much went out, which in this case would still be from 0 to 5 with my, what is it, D of t? dt. Did anyone get a number for this? Yes. Yeah, so this is kind of how much was there at the start. That's just our number. I don't need a 3 there. Go away. Oh, no. Right, whatever, that 3 is just going to be there. Then we want to add how much kind of water went in. Since we were given a rate for that, that's why we need to integrate it. So we're integrating back to an amount of water. Here we're just going from 0 to 5 because water is flowing in from 0 all the way up to 5. And then we're going to subtract how much water went out. Again, since we had a rate out, we have to integrate back to get an amount of water going out.
Why are we like subtracting it like out?
Finding that by.
So can you rephrase your question really quickly? I want to make sure. No, I just want to make sure I'm answering the right one.
No, it's like, it's asking for like T is 5, but why are we adding like 1 and subtracting it up? Is it because they're both going in and out?
Yes. So these are both giving amounts of water. So the rate out isn't necessarily going to give us like a negative amount of water that's leaving. We have to know this is giving us a positive amount of water that we want to have left. So we have to like physically take it out with our subtraction.
Okay.
Better?
Yeah.
Okay, there.
So for the amount that you know you're at.
Yeah.
The 10 plus. Is it okay if it was at the end of 10 plus?
Oh, yeah. If you change the order of any of these, this is perfectly fine. The one thing you just want to make sure is that your DTs are here to close off your integrals. You could actually also combine the rate in and rate out, since these ones in my question right here have the same bounds. We could do the integral from 0 to 5 of R of t minus d of t if you wanted to. That would also be legal. All right, I don't know what the number is, but number's not super important. Here, a couple of people got the wrong units. I may have highlighted them, but here I can't grade the units because I didn't ask for them. But if you want to get in the habit, these would both be feet cubed. Did you want to? I didn't want to type it all. I didn't want to type it all in. Did you have an answer? Say that again, slower. This is according to Derek. And Chris, apparently. I trust them. Their tests look pretty good. We'll figure it out later. It might just be a typo. All right, so what I'd like to do right now is to transition a little bit into our U-Substitution. I want to get as much done as we can today. The notes next time are relatively short. So the more we can get done today, the more problem set time I can give you guys next time. And I want to do a lot of the problem set during class, so much so that I'm going to motivate you by pulling out stickers and giving you stickers when you get your problems right. Right? Fun. Yeah, we're going to do that on the problem set. I don't have a notes check today, so I just really want to get some of this problem set done. But I have to teach you some stuff first. That's not a hand. That's a high five. So I'm going to hand out some notes. The two big focuses of today's notes, one, just practicing with U-Sub again. And then 2, trying to make sure we know what to do with bounds and what to do with logs. Yeah. Yeah. Sorry.
No.
Don't be sorry.
Don't be sorry.
Thank you.
That's all right. All right. Actually, this first question on here is not super easy, so I'm going to make one up really quick. If you want to do it with me, you can do it on the back. Your notes are blank on the back. But I just want to do one that's not the first question because it's a little aggressive for a first question. We might not get to all of them today. What did I do this weekend? Hung out with my husband's friends from work. What do we do? We went. He is an accountant for government contracting. Oh, do you run track too?
Yeah, I started.
Fun. Are you a sprinter?
Yeah, I kind of like looking at throwing.
Oh, that's fun. 7.2, U-Substitution. Bounds and logs. All right, did we do all the ones from? All right, 7.2. All right, let me make up one really quick that we can do. Yeah, if you want to follow along, you can do one on the back. Let me make one up. What did we do last time? Let's do, or do we have one that we didn't do last time? No, we did all of them. Yeah, we're going to just do one practice question on the back before we get going. So, can someone chuck out their favorite number? 5, 8. All right, so if you want to follow along and do this question, I'm just going to do it on what effectively would be my back page of my notes. So let's do x to the fifth. All right, so if you want to follow along, write this down on the back of your notes. We're going to talk this one through really quick, just to remind ourselves what the heck happened with U-substitution. So first of all, why would this be a good question for U-substitution? All right, it looks like a chain rule. It looks like there's a function inside another function. So does anyone remember what we would have called U in this question? X to the 6 minus 2. Thank you, Herbie. It is our inside function. Does anyone know what we did after this, after we chose? All right, we found du, which was the derivative of u. What is the derivative of x to the 6 minus 2? All right, what do we usually put after our derivative for this? Let's go dx. Perfect. All right. All right, Sadie's right. Oh, you guys were listening when we learned this. We're going to divide by 6 because, does anyone remember why we would divide by 6? Ooh, I like that phrasing. We want to make it equal to kind of the leftovers, the outliers in this guy. So I did a lot of highlighting when we did this in our notes. This covered our inside. That was our u. And then once we got this part, that was equal to everything else with our du. So we notice we have coverage for almost everything in here. Yeah, Herbie. So we were looking to kind of match everything in the integral that wasn't our u. So notice we have the dx at the end, the x to the 5th. Exactly. So we moved that 6 away. We had a couple examples where we multiplied by something on both sides to match a number in there, but we could always just divide. So let's talk about rewriting this integral. What is this going to look like when I rewrite it in terms of u? All right. All right, there's going to be a u to the power of the 8th. I agree there will be a du, and Derek said something that I know we're missing, the 1/6. Now, I put this out front a lot of the times. It doesn't really matter where you put it, as long as this guy du has to be at the end of our integral. That's what closes out our integral, so it has to be at the end. All right. The question we asked ourselves a lot of the time was, does this look any better? I would argue in this case, yes, this definitely looks better and easier to integrate. So I'm going to do that right now. I'm just going to leave the 1/6 for a second. What is the integral of u to the 8th? No. How do we integrate things?
Oh,
there we go. 1/9 u to the 9th. We are just going and adding 1 to the power, dividing by that new power. If I left this like this, I'd get highlighting for a couple of things. All right. The lines for bounds. Do I have bounds? All right. I need to plug in my u before I even get there. What's missing at the end? Plus c. If you have that missing on the test, you're going to get some big old yellow highlighting right here. Most of you remembered your plus c's, but that has to stay. And then you guys are right. I can simplify. I don't have to, but I'm going to. 1/54. And I need to plug my u back in. That's x to the 6th minus 2, all to the 9th power. So what we're going to talk about today, I actually have no idea when we get out of class today, so I'll look that up in a second, is we're going to talk about a couple of different scenarios. The first is going to be a little bit weird. And I want to preface this by saying that this does not happen all the time. This is going to be like maybe one question on your test, and I know one question on your problem set does this. So just give a preface for how interesting this question is. It's cool. I like it, but it's definitely a weird conversation. So it's 1:25 when we get out?
Yeah.
12:45? I know. There's a net. All right. Do you think this question needs U-substitution?
Yeah, it does. If you simplify it, then it's 2x minus 1 to 1/2 power.
Ooh, okay, cool. I like that idea of a 1/2 power. I'm going to save that idea. We're going to come back to it. So what do you guys think U should be? All right. Then what? Okay, du, the derivative of u, okay, is just 2 dx. All right, I am starting to see an immediate issue here. Okay, let's talk about it. So we have this. Kind of going back to what we just did, do we have this 2 in our integral? No, so I'm going to do that divide thing that Sadie was talking about before. I'm going to divide by 2 here to just plug in for dx. Yes. What about the x? So you guys are noticing the big problem. We are not in multivariable calculus. I don't do integrals where there are multiple variables. We would have to ask Quinn for help, and he doesn't want to. So we got to figure out another way to do this. So I need to think of, let's see, is there a way that I could get something that's like x equals something with u's in it? Is there like an equation that just has x's and u's in it that I could solve? Oh my God, Herbie, how brilliant. Holy moly. So we're going to take this equation, and what we're going to try to do is we're going to try to solve it so we get x equals something with u's in it. We're kind of hoping that if I do that, I might be able to simplify and get something I can integrate. Pretty sure it's not going to be pretty, but that's okay. We can deal with it. All right, I'm going to add 1 to both sides. Y'all are going too fast for me. And then I'm going to divide by 2. So I have u plus 1 all over 2 equals x. So what I'm going to do is in a second, I'm going to plug this big old fraction in for x. Again, so I took the one in yellow here, and I'm going to try to solve it for x because I need something to plug in for x. So I decided to add 1 to both sides to get the u plus 1, and then divide by 2 to get the x by 2. Am I recording this? Absolutely. Yeah. All right. So this question, again, I'd like to preface, there are, in your problem set, there are 10 questions that are just straight up U-sub, and then 3 more with bounds. So there's 13 questions of U-sub. There's 1 like this. So this does not happen all the time. So we're going to go and we're going to plug in now. Now, there are a lot of things I'm plugging in, so I'm not going to get fancy about like where I'm putting everything. I'm going to put everything exactly where it is. So instead of x, I can write u plus 1 all over 2. Hold on. Hold on. Instead of square root of 2x minus 1, what can I write? All right, I can do square root of u. I'm going to do what you're saying, Derek, in a second. We're going to save that 1/2 power. I'm just trying to plug in right now and not worry too much about anything else. And then instead of dx, what can I write? 1/2 du. Now, let's reflect on some of the questions I've been asking. Does this look better? Arguably, maybe, maybe not. I like that there's not a function inside a function anymore. So we might be able to integrate this, but it doesn't necessarily look better. It is, though, all in terms of u, which is positive. We don't have x's and u's in the same equation. So I'm going to try to pull some things out to make this look a little bit better. And I'm going to finally use that 1/2 power you guys are talking about. So I'd like to take, I see 2 1/2s in this question. Do you guys see 2 1/2s?
Yeah.
All right, so I see this 1/2 here, and I see this divided by 2 here. They can't cancel, but I could multiply them together. What's 1/2 times 1/2? 1/4. And I'm going to pull that straight out all the way in front of the integral. I can do that if it's a number. Then on the numerator, I still have u plus 1, which I'm going to keep in parentheses. And you guys have been telling me since pretty much the beginning of this problem that that square root is u to the 1/2. Thank you. All right. So it's still not looking great, but I would argue it's starting to look like something I might be able to integrate. Am I able to integrate products like this? Do we have a product rule at all? All right, then what can I do? Not yet. What was your idea, man? Yeah, distribute. Perfect. A couple of you did this great on the test with pulling that, I think it was like an x to the -2 up and you distributed. Yeah, perfect. All right, let's get these powers going. Let's see. So this is u to the first times u to the 1/2. Do you guys agree with, I think Herbie said 3/2 here for the power? Ah, yeah. Plus u to the 1/2. All right, let me check. Make sure. That looks good to me because 1 is 2/2 plus 1/2 is 3/2. Yeah, now we are ready to go because we have number times u to a power, number times u to a power. There's no products, there's no quotients. I'm again going to kind of leave myself the room to let the fractions linger out later. So let's talk about the new power on u to the 3/2. What will the new power on that guy be? Oh, good. I love when my computer freezes.
What the heck?
Yeah, 2/5 u to the 5/2 is great. Why don't you guys, while I'm getting my computer to decide it wants to work again, why don't you guys try to integrate the rest and plug back in your bounds? If you're feeling extra spicy, try to simplify your fractions. My computer does not think very quickly. See, it's still recording though.
That's good.
It still records, but it stops presenting my screen, which is a little bit interesting.
Why does it happen?
I don't know. I think because my old computer didn't do that, and I was doing all the same things. I do have a lot of things open currently. All right. So you guys had 2/5 here. What did you have your next term look like? Perfect. What am I missing? Plus C. All right. So this is done, right? We're good? I could. Can I leave it like this, though? I had to plug in my U. So I'm going to personally simplify just because it makes me happier. That would give me what? 1/10. What is U? 2x minus 1 to the 5/2 plus 2 over 12, 1/6. Am I doing these right?
Yeah.
Thank you. I'll have my notes in front of me. Winging it, y'all. Just winging it. All right. So not the worst thing in the entire world. Also, not my favorite question in the definitely a little bit more challenging. Again, this will not happen very often. This is what happens when there's kind of an extra x that's not covered by our dx, all powered by that u equation. Miss Sadie.
So when do we know like it's time to take the
Yeah, so I heard Matt say it. He was like, we're ready to go when we got to this step. Notice that we have u's to kind of single powers. There's nothing being multiplied with multiple u's. There's nothing being divided with multiple u's. Essentially, when you have like number times u to a number power, you're ready to go. So we're kind of separated with terms there. It's a really good question. Yeah. I did 2/3 times 1/4, so distributed that in. So 2 over 12 or 1 over 6. Yeah. All right. I would like to do one of these questions, and then I think I'm going to have you guys try one of them if we're feeling brave enough. So I know you've been sitting here and you've been like, man, I like all of this, but what happens if I have bounds? So let me tell you. You're not going to like this, so we're going to practice it a couple of times, but it's going to be cool. So let's just start. Does this question need U-Sub? Yeah? If it does, what's U? X squared plus 1. We want the function that's inside the other function. All right. So if that's what u is, what's du? 2x dx. All right. Looking at the 2x dx, do I have all of that in my integral, or should I try to move some stuff? I don't have the 2. I can divide by 2. Now, are we in this weird situation where, like in the last one, we're going to have to solve for an x at all? No. And the nice part about that is looking at what we have covered. We have this guy in here. And then we all have this x covered because it's part of the du that I'm solving for. So not all the time will an x out front have that problem. All right, so let's substitute in. We'll kind of see what's going on. Instead of this x squared plus 1 cubed, I'm going to put u cubed. Why is everyone walking past this spot? But you don't have to walk by here, you know? There's really no reason to walk by here at all. I don't feel popular. All right. Yeah. So I'm kind of keeping track of what my u is, so the function inside the other function, and then what I'm substituting in for, that x dx is that 1/2 du. So kind of just keeping track of what I'm substituting for. Because we had this extra x here, so that was when we had to solve for that extra x using the u equation. All right. So for this guy, when I plug in for x dx, I'm going to do 1/2 du. Are you guys cool if I put the 1/2 out front? Thank you. I agree. All right. What thing is super glaringly missing? The bounds. Now, these two bounds right here are x values. So technically, I cannot put them on the integral that's right here because this has u's in it. So I need to make sure these two numbers are u equals something. All right. Do we maybe have an equation that says u equals that I could plug x's into? We do. Exactly. If you're ever curious about what thing to use to do anything in U-Sub, it's usually the u equation. So what I'm going to do is I'm going to plug in x equals 0 and x equals 1 into the u equation. So let me see if I can label this really well. So x equals 0 and x equals 1. I'm going to plug them into this u equation. So I've got u equals 0 squared plus 1, which is 1. That's going to go where the bound was that I plugged in. This guy, I'm going to do 1 squared plus 1 is 2. So that's going to go at the top. If you want to clean that up, you don't need to write the u equals whatever. So normally I'd probably write it like this. Now, why would I ever want to do that? It seems like a lot of work. Yeah. Because they're in an integral with x's in it. So if they're not labeled, you're assuming that those values are whatever values in your integral. So just like when we set up some of our position velocity stuff, how it was like dt at the end, and those were times that we plugged in, whatever's in there, we're assuming those are the letters. Exactly. Exactly. And I like your use of the word corresponding, because even if these had like switched which one's bigger or smaller, we have to keep them in the same kind of corresponding location. Right. So we're going to use that vertical bar. So the nice part about changing the bounds is I can kind of now pretend that this original problem didn't exist and I just have to solve this one. I never have to plug the x's back in. I never have to do any of that because this is now an integral that's entirely in terms of u. Why am I allowed to change the bounds? Because I have to, because I need them to match the letter that's in my question. So they need to be u values if this kind of statement is going to be true. So it's because we're now working with an entirely different variable. So the two graphs that we're looking at are entirely dissimilar now because we're talking about u cubed and this graph right here, which would be an entirely different graph. But you're working with variables. Since we're using a change of variables, I'm trying to ensure that this thing equals this thing. So the area under this graph from 0 to 1 is equivalent for the area under this graph from 1 to 2. So they're two entirely different graphs now.
So as soon as you change the variable.
We change the bounds. All right. So let's go ahead and integrate this guy. We're going to integrate this with bounds. What is my integral of u cubed? 1. There we go. We actually have to do our integral. And we're going to put our bounds 1 to 2. Now, these are u bounds. So they get to go directly back into where the letter u is. So we don't have to plug the original back in because those were x bounds at the beginning. So the x's would go to x's, u's would go to u's. So here I can plug straight in and I can go, just doing 1/2 times 1/4 is 1/8. And go 2 to the 4th minus 1/8, 1 to the 4th. Anyone know what 2 to the 4th is? 16. So I'm doing 16 minus 1 all over 8, or 15/8. Now, I could do this a longer way, and I would recommend not writing this down. Whoa, hello. Some people do like to plug the x's back in. So if you got down to the 1/8 u to the 4th, if you plugged your x's back in, so your x squared plus 1 to the 4th, what you would have to do is now use your original x bound. So you could go from x equals 0 to x equals 1. You just want to make sure that whatever you're plugging in needs to match the letter that you're going with. Yeah. This answer right here. All right, so graphically, let me grab business. Graphically, it means that the area between 0 and 1 of x, like the original integrand, is 15/8, or the area of 1/2 u cubed from u equals 1 to u equals 2. So both are equivalent areas. They're just kind of different looking. Let me see if I can show you. What was the first one? X squared plus 1 to the cube. Is that going to do what I want? No, that's not going to do what I want. All right. So this is, and we wanted to go from what, 0 to 1? All right, so there's the area that we found. So that's 15/8, but 1/2 x cubed. Oh boy. All right, that green one is the second area we found. They're equivalent. They're actually the same size, but they do represent different portions of the graph. So that's why we have to use different.
They're both 15/8.
Yes, so they're exactly the same size. They're just kind of different integrals that mean the same thing. So the reason we're using U-substitution is this one's a little easier to work with and kind of contextualize, but they do have equivalent areas. Yeah. Yes. All right. What I would like to do before we keep moving on, I would love if you guys could try the next one. So I'm going to put up a timer that's a little bit longer than you probably need. I'm going to put up a timer for 7 minutes. Hopefully that's longer than you need. If you need to go to the bathroom, you can do that. But at the end of the 7 minutes, I'm going to try to go over this integral right here. It does need U-sub. It does need you to change your bounds. Requires some negative exponents. So try this one, see how far you can get through it. We'll go over it at the end of 7 minutes. Yeah. Yeah.
So for this part, we're just saying that like, so I just said one's like x equals 5 and then where do so wherever your u equation is, you're gonna take whatever bound you have, plug it into that u equation and put it in the corresponding place. So like for 5, that minus 1 is 9, so your new top bound is gonna be 9. This one you plug into that equation, whatever x equals 5, it's like what is this like? Where's this u squared from?
I think she should be you.
Here. So we're just saying that it's like the u.
So we're just translating the, yeah, you're just translating that so every equation makes better. Not a very good common time.
It smells like
It smells really good.
yeah.
Oh, you use this u equation to figure it down? You could think, I like what you're going through now, when you have your one round and going, but eventually, when I integrate that, I'm gonna want to get into the degree of refraction. I think about what power you have.
So it's a 1/2.
I usually put my d out to the side,
Yeah, okay.
and then I almost always take that fraction out front.
Okay. So is it just gonna be a 1 on the top then?
You added one to the
So now like we end up right.
Okay, so it's
Okay, so
you want to study side
and now
Yeah,
okay.
so now notice your eyes in your brain,
Yeah.
going number times the weeks. And move for bigger.
strength. It's like reading the Bible.
Do I have to solve
Yeah.
from like here?
You got that. Oh wait, you never knew. Good. Here, you're gonna add one. Somebody. No, you have tiny little.
Yeah, you're right, tiny, and that's the fact. It's very- the numerator. Put it to the X. I'm the only one.
I just talk to the outreach team, they're the ones that are gonna update or not approve.
I think I might end up doing that.
Yes.
Okay. Sounds good to me.
Are you looking?
Has anyone tried my problem?
You write it
Did anyone get an answer? Yeah.
So is that only for like
Okay.
We'll do some more, just like
What is that?
like I don't. I didn't like it. Oh yeah.
So when I'm plugging, that's what I'm doing here, and then plug in 9 and I subtract it by the same vector.
All right. I know exactly what I would like to do. All right, let's go ahead and walk through this problem. So if you started this problem, what did you do? What was you? Cool. All right, which made du? All right, do I have all of that? Cool. All right, so when I'm plugging in, I put my 1/2 out front, my du at the back end. I had 1 over the square root of u, and then I wanted to plug in my bounds. A reminder, we're plugging into this top equation. So my new bottom bound is going to be 2 times 1 minus 1, which is 2 minus 1 or 1. My new top bound is going to be 2 times 5 minus 1, which is 10 minus 1 or 9. Now, a handful of people are forgetting that at this step, you really still do have to integrate. We've done a lot of algebra here, a lot of substitution, but we haven't actually done the calculus yet. So we need to continue doing that. I would like to do my power rule, which means I'd like to have u to a power. What are your thoughts on that power? All right. I like the 1/2 from the square root, and I like the negative from bringing it up from the denominator. Now, I don't want to plug in my bounds right away, though, because I haven't actually integrated yet. My integral is like the add 1 to the power divide by new power. So my new power, let's see, add 1. Is that 1/2 now? All right. And then 2. What does Derek mean? And then 2. All right. My new coefficient can be 2 because I'm dividing by 1/2. So this is my actual integrate step. U-sub, for some reason, it gets so cloudy that sometimes we forget to actually do our integral. So just make sure you're actually doing calculus. I heard a couple people say, hey, can you cancel those 2's? Absolutely, I would. And now I want to plug in my bounds, which are 1 and 9. Now notice, I am never going back to using the x's because I transferred my bounds into u numbers. They should go into the letter u. Speaking of simplifying, how do I do to the 1/2 power? What's that the same as? A square root. So I'm going to do square root of 9 minus square root of 1. Last time I checked, that's 3 minus 1 or 2. All right, so yes, this problem is long. Yes, it's kind of overwhelming, but we will take it one step at a time and be good to go. All right, I'd like to do a couple more questions. What do we say? 25 is when we're leaving? What? Can we do 2 more problems, one of which is really, 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 really short? Okay. What? Pretty much. Yeah. All right. I wanted to show you what the integral rules for natural log are. You might be saying, integral rules for natural log? There are no natural logs up there. And that's because we're going to integrate into natural log. Do you remember who had a derivative of 1 over x? I literally just said it. It's natural log. Now, can you plug any numbers you want into natural log of x? No, you cannot. You can only plug. Anyone know what kind of numbers you can plug in? Even more exclusive than that. Does anyone have a calculator near them?
I do.
Try to plug in natural log of -1. Has to be positive. If you do that, you're gonna get undefined. What's a function in that we've used before that lets us make things always positive? Absolute value. We're gonna slap some absolute value bars on the inside of our natural log to make sure that that innard is always positive. Miss Hefty, if I forget my absolute value bars, will you take away my points? Yes, because then it's wrong. This is just a reminder that we can do U-sub with these. So this is natural log absolute value of U. All right. As a hint, kind of like when we did exponentials last time, like when we set U equal to the exponent, a good hint is try U equals the denominator if you don't know what else to do. So I'm going to try these two, and then we're going to be done. Does the first one need U-sub? No, the bottom's just x. So I could write this as like 2, the integral of 1 over x dx. 2, when I integrate 1 over x, what function is going to pop up? Natural log absolute value of x. Now, just to be very, very clear, that works for 1 over singular x. 1 over x squared, I would still want to write as x to the -2. Actually, the reason this happens, how would I rewrite 1 over x as x to some power? What would happen if I add 1 to this power? That would be 0, and I would divide by 0. Yeah. Can't. How do you split 1 cookie between 0 friends? You don't. All right. Last one. Does this one need U-sub? Is the denominator just x? No. So what do you think U is? Then what's du? Dx? Do I have that 4? All right, let's try this then. So I got a 1/4 out front with a du at the back end. What will the integrand look like now instead of 1 over 4x minus 1? 1 over u. All right, I'm going to keep the 1/4. When I integrate 1 over u, what will I get? Natural log, absolute value of u plus c, and I'll plug my u back in. 4x minus 1. Yep. What? No. So we don't want to absolute value those things individually. We would want to absolute value whatever number we would get once we plug the x in and like simplify. Yeah, there's like a whole function inside in there. All right, so what I would like to do right now, we have about 10 minutes left of class. I'm going to hand you out your problem set. I would like you to make it your goal to get 2 questions done from numbers 1 through 13. You can't do all of them, but there's certainly a lot of them you can do. So I want you to find 2 of them. I'm going to walk around with little monsters stickers. And if you get one right, I will give you a sticker. And then you know one of your problem set questions is right. So goal, 2 questions. Pretend it's like a note step and you want to get it done. Also, please bring this problem set next time. I'm going to put a big chunk of time into work on it with stickers on it.
What happened to the buff?
What?
You have a little friend.
Oh, yeah. Sorry. Yeah, I wouldn't do 9. Yeah, don't do 9. Or 7. I know. All right, I'm going to put a list of the problems you can do on the board. One. Oh, number 6 is like the hardest one. Number 4 is so much easier. 6 is the hardest one on here. I'm not lying.
6 is easy. I would say it's hard at all. But number 1.
Ooh, 8's hard too.
You really gotta throw 6 is first question.
What?
How is
Trig's not hard.
how is 6 hard? It's like that's the problem. It's too hard. I give up.
What would you be for number 6? What would you be for number 6? X minus 5. All right, what's DU? What's DU then? All right, so where are you getting that extra X there from? That's why it's hard. You want the easiest one on here? 1, 4, 5. Those are the easiest ones. Just because it's bigger does not make it harder.
To the contrary.
3, really easy.
3.
Actually,
You might be right.
you get that.
Oh, just wait. If you guys take BC next here, U-Sub comes up all the time and they miss it all the time, just like chain rule. So like, what do you think you should do? And they get so tired of me. I'm gonna say number 3 is super easy. It matches. I also think I lied. I think there's 2 with the extra.
So it's fine that this doesn't match this.
It's just online, nothing.
Every other sticker is wait, is there a small one?
Oh, yeah.
I did it.
You're gonna need some U-Sub. I would say you
No.
I read my use.
Yeah.
So this is B over there.
Oh, right.
Each side is gonna be.
Can I say this?
Oh, yeah.
I'm working on
this.
And then now that you have 2 power, now you're accepting the atom of the right. So you don't need to, because your X is here. So your X
Oh, I
is
forgot
gonna
to
be
say it.
Yeah.
Oh, it's at 6 where we got that one.
It was the average stick was.
And then that means you.
Here, one more step.
Like,
Yeah.
Seriously, I was teaching and I was like, oh, you should have said no. You should have waited. No, it does.
All right, you said 25.
Yes.
All right, guys, we have about 3 minutes left of class. Let's just. I said 2.
Oh, I did 10.
Does anyone listen to me ever? I'm convinced no.
No, I was listening. I just got
No, no one does. It's fine.
I was just mistaken.
All right, so some favors from you guys. 1, what's happening at the beginning of next class? Round 2, that'll be 20 minutes per use. Please bring your problem set next class. I'm going to try to shorten the notes as much as humanly possible. Yes. This problem set, I'm going to try to give us a chunk of time. We might be doing some problem sets instead of notes checks. You guys have a lot of notes checks right now. I'm sorry.
Yeah, I wanted to actually.
But now I want to see because I feel like
Hello.
you.
Whoa. I would challenge how you did this one. You want to make sure you divide by your new power, not multiply. Also, you got to keep your integrals in front of those guys.
Yeah,
But you're
okay.
on the right track, definitely.
So erase the 35
Yeah.
replace it with 1 7
Oh,
or 5 7, right?
That sounds about right.
Okay.
All right, we have less than a minute, so figure out yourself
I did.
for me.
Yes.
Thank you.
I want to figure out the second question.
Ma'am. Weeks? I don't know what it is. I think there's like a day within a week. There's like a week. I feel like April. I don't know. No one ever appreciates me at the time. I'm gonna say at the time of the year it is. I feel like everyone's just burnt out, so we never get appreciated.
I make something for my teacher.
Oh, I would love that. I would say Ketterman's does a cool thing where they usually give out like a gift card to teachers.